I'm doing a voiceover on this video because the original video didn't record my voice. So if it seems a little weird in parts, that's why. All right, so here we have our rate equation. It's the order. We're going to use this data in this table here to fit this equation that we have. We already figured that out. So it's x to the second, y to the first. And what we want to do is solve for k. We want to solve for the constant, the rate constant. So what you can do is choose any one of the trials in the data table. And they're not labeled 1, 2, 3, 4, 5. We're going to choose any one of those, and the equation we're going to solve is the rate constant is equal to the rate over concentration of x squared and the concentration of y to the first, because we've already calculated that it's second order with respect to x and first order with respect to y. So here are the trials 1, 2, 3, 4, and 5. And like I said, you can choose any one of those to substitute into this equation, the rate in the top and the concentrations in the bottom. All right, so let's say rate 4 or trial 4. So we're going to take the rate, which is 0.254, from the rate column, and we're going to put it over that, the concentration of x, which is 0.1, and that's squared, because that's second order, and then y was a 0.3, and that's first order with respect to y. So all we have to do is solve this problem right there. So let's go ahead and go to your calculator, start your calculator, or if you're using a regular calculator, go ahead and grab it. I'm using the TI Nspire software that I sent to you a couple of months ago. All right, so go ahead and hit the control divided by to get your box over a box. 0.254 goes in the top, and in the bottom we're going to have 0.1 squared times 0.3. And when we press equal, we're going to get that it's 84.666. All right, so 84.67. And we're not going to have to worry about the units here because all you're having to do in Canvas is put in the number. So let's just round that to 85. Now, just for your information, it's going to be liters squared, seconds to the -1, and moles to the -2. All right, so that's all you have to do for that is substitute in those numbers from one of the trials in the data table. All right, so the next question. This one's kind of tricky, and the only reason it's tricky is because it asks you to take a certain amount of lithium and calculate a rate. It gives you 3.97 minutes and calculate it in liters per second. Now, the reason this is so tricky, it's not because you don't know how to do it. It's asking you to do stoichiometry, which is way back in your memory banks. But we have to use it in order to get the rate that it's asking for here in the question. So we have 2 moles of lithium that's combining with 2 moles of hydrochloric acid. We have 396 milligrams of the lithium. Okay, and it's reacting to give 2 moles of lithium chloride and hydrogen gas. And we need to calculate the average rate in liters per seconds. So what we have to do is figure out, if we're starting with 396 milligrams of lithium, how do we get liters of hydrogen? Okay, so remember, rate is equal to the change in quantity over the change in time. So we need to find a quantity for the hydrogen. and we're starting with 396 milligrams. So as I mentioned, we have to use stoichiometry in order to do this, and we know how to do stoichiometry. Remember, stoichiometry is taking liters, or taking some milligrams here, some quantity of one element or compound, and calculating a quantity of a different element or compound. In this case, it's hydrogen. All right, so we're going to start with our given, which is 396 milligrams of lithium. Put that over 1. And we want to do a conversion. We want to convert this to liters of hydrogen. So in our first conversion, what do we want to get rid of? We want to get rid of the milligrams. So we're going to put that on bottom, and then we're going to convert it to grams, which is on top. Because ultimately we have to get to moles. So first we want to get from milligrams to grams. Well, remember, there's 1,000 milligrams per every gram. So cancel what you can cancel. So we're going to be canceling the milligrams. Make sure you write your units in and the full unit. So that includes whatever element that we're working with at this moment. So grams of lithium is what we have left over. Now we want to take this grams of lithium and we want to convert this to, this is stoichiometry, remember, so we're going to have to get to hydrogen somehow. The only way we can do that is a mole to mole comparison. So we want to get rid of the grams of lithium and convert it to moles of lithium. So 1 mole is how many grams? Well, in order to find this, we have to go to our reference materials, and we're going to look at the periodic table. Right there it is. Okay, let me pull this over. All right, so lithium here we see is 6.94 grams per mole. So 1 mole is 6.94 grams. Cancel what you can cancel, which are the grams, and we're left with moles of lithium. So now we can take this equation that's already been balanced. We want to get rid of moles of lithium and convert that over to moles of hydrogen. Now from our balanced equation, we see that it's 2 moles of lithium, and it's already balanced because you see the coefficients here. So 2 moles of lithium make 1 mole of hydrogen gas. All right, cancel what you can cancel. We're left with moles of hydrogen. But we don't want moles, we want liters. So we have one more conversion that we need to do. We want to get rid of moles of hydrogen and convert this to liters of hydrogen. Okay, so from the mole map, do you remember what this conversion is? 22.4 liters is equal to 1 mole. So cancel what you can cancel. Now we have liters of hydrogen, which match what the question is asking for, liters. So all we have to do is the math here. We can get how many liters goes on top. All right, so this is 396 times 22.4 for the top. And in the bottom, we're going to have 1,000 times 6.94 times 2. All right, and press enter. That's going to give us 0.6391. 0.6391. And that's liters of hydrogen. So this is what's going to go in the top there. All right, so now we need to get liters per seconds. And in our problem here, it tells us minutes. So we have another conversion that we need to do. We need to convert 3.97 minutes to seconds. So we want to get rid of minutes, put that in the bottom, converting it to seconds, that goes in the top. 1 minute is 60 seconds. Minutes cancel, so you're left with seconds, so it's 3.97 times 60. All right, that gives us 2.382 times 10 to the 2. Wait, did I write the number wrong? Yes, 2.3, not the other way around. Okay, let me erase this. 2.382 times, what was it? 10 to the 2. And that's in seconds. So that's what's going to go on the bottom there. Okay, so let's make sure 3.97 times 60. Okay, and 2.382. Okay, so that's what you do in chemistry, is you make sure you go and double check every step of the way, because since we're doing so many steps here, we want to make sure that we don't make a little mistake in the details, which is going to throw off the answer to the problem. So check, double check, okay, make sure you have the right numbers written down. All right, so 0.6391 over 2.382 times 10 to the 2, and this should give you liters per second. All right, so we're going to get box over a box, 0.6391 in the top, and in the bottom, 2.382 times 10 to the 2. All right, so that gives us 2.68 times 10 to the negative 3. Okay, 2.68 times 10 to the negative 3. All right, so in Canvas, it doesn't ask you here for a scientific notation. It asks you for this in standard notation, and it's at 4 decimal places. So what we're going to do is have to take this number right here, and we're going to have to convert it over to, oops, nope, not 0.2. Write the number down correctly. Okay, 2.68 times 10 to the negative 3. Okay, so we're going to have to move the decimal 3 times to the left because it's a negative 3. So I'm going to add some zeros in here. 1, 2, 3. All right, so it's going to be 0.00268. And it wants 4 decimal places. So 1, 2, 3, 4. So this 8 here is going to round this 6 to a 7. So it's going to be 0.0027. The correct answer there for Canvas. All right. So that's how you work out these problems. These are 2 problems that you're going to find on your quiz. So if this helped you out, make sure you slap that like button right across the face. Make sure that you subscribe, and make sure that you click the notification bell so that you know when I put videos up like this that work out problems on your quiz, so that can help you out.